Here, the stoichiometry, which means element. So we need to calculate the relationship between the mass and the mass. Carbon dioxide is obtained from 16 gram of methane. So here you can see that the hydrogen combining with the oxygen forming water. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were discussing with the unit called Some Basic Concepts of Chemistry. Under that, we have discussed about the mole concept, and we have understood that mole is a new word that used to identify the numbers of entities which is found in a compound. And we have found that 1 mole which is equal to 6.022 into 10 to the power of 23 atom per mole. Right? And also, we have discussed about the percentage composition. So, if any compound which is given to you, you can clearly say that how many elements are present in a which composition, you can clearly say by using the percentage composition formula. And also we discussed about the empirical and a molecular formula. So the empirical formula which gives a idea about the ratio of the atoms of the element which is found in the compound. Whereas the molecular formula which gives a clear picture about the how many number of atoms or how many number of elements which is found in a given compound. So this is how the important concepts in a chemistry we have discussed in the last class. Today let us move on to the next topic of this unit, that is stoichiometry and stoichiometric calculation. In addition to this, we are going to discuss with the limiting reagent. So first we will directly move on to the stoichiometry and stoichiometric calculation. So in chemistry, the stoichiometry, the word which comes from the two different words. Okay. So the word stoichiometry which comes from the two Greek words. Here the stoichion which means element. The stoichion means element and metron means measure. Metron means measure. So the stoichiometry which comes from the two Greek words, stoichion means element and metron means measure. Okay. So what we are going to do in the stoichiometry, we are measuring the elements. Okay. Or we can say that in simple word, the stoichiometry that deals with the calculations of mass of the reactant and a product that are involved in a chemical reaction. Mass of the reactant and the product that are involved in a chemical reaction, that is find out by using a stoichiometry. Understood? So before going to understand how to calculate the mass of the reactant and the product which is found in a chemical reaction, let us understand few things regarding the chemical reaction. So here I am taking the example of combustion of the methane. Okay. In this you can see that I am taking the methane which reacts with the oxygen forming carbon dioxide and the water. So here you can clearly say that the equation is not balanced, right? Because the only one carbon is there and one carbon is there, so it is balanced. And you can see that only 4 hydrogen is there, but here only 2 hydrogens will be there. So for my convenience, I'll write 2 here to balance the methane which is present on the right hand side. Okay. Next, coming into the oxygen. So how many oxygen will be there here? So here also 1 and here also 1, but here also it is 1. So I'll write 2. So because it already become, I have written 2 to balance the oxygen. So that side also it become 2 oxygen. So before going to calculate the mass of the reactant and product, we have to see that whether the equation is balanced or not. After that, you can clearly say that the reactants are the methane and the oxygen, not water, oxygen. They are the reactant. They are the reactant. Understood? So the carbon dioxide and water, they are the product. They are the product. So here you can clearly say that there are two reactants, they are combining together and forming a product. Okay, and in that you can clearly say that the reactant one, that is the methane and oxygen, they are present in a gaseous state. Whereas the two different products, that is a carbon dioxide and water, one which is present in the gaseous state, whereas another one which is present in the liquid state. And also here I have written 2 oxygen and 2 water. Right? So here what does it 2 indicates? The 2 is nothing but a stoichiometric quotient. They are the stoichiometric quotient. So these are the basic things that you need to understand before going to calculate the mass of the reactant and the product which is found in the chemical reactions. Understood? Now we can express this equation into the 4 different terms. So how we can express it? The first term we can express in terms of mole. Okay. And we can also express this equation in terms of molecule. And also we can express this equation in terms of mass and also in terms of volume. In terms of volume. Let's see how to define this equation by using 4 different terms. First, I'll go for the mole. Okay. So here we can say that 1 mole of methane reacts with 2 moles of oxygen, forming 1 mole of carbon dioxide and 2 moles of water. How we can define it? The 1 mole of methane reacts with 2 moles of oxygen, forming 1 mole of carbon dioxide and the 2 moles of water. So this is in terms of mole. Coming into the molecule, how we can define it? 1 molecule of methane reacts with 2 molecules of oxygen, forming 1 molecule of carbon dioxide and 2 molecules of water. This is how in terms of molecule also we can easily define the following equation. Coming into the masses. Okay. How we can define in terms of masses. So if you want to express in terms of masses, we need to express in terms of grams. So how to express it? We know that for the methane, carbon and hydrogen are the 2 different atoms will be there. For the carbon, atomic mass will be 12, right? Atomic mass will be 12. For the hydrogen, it is 1. 1 into 4, that is 4 only. So it totally becomes 16 gram. 16 gram of methane reacts with how many grams of water? So here 2 into 32. Why it is 2 into 32? Because the atomic mass of oxygen is a 16. So 16 2s are 32 into 2, because 2 molecules of the oxygen or the 2 grams of oxygen will be reacting. So we can say that 16 gram of methane reacts with 2 into 32 grams of oxygen, forming here, if you calculate the atomic mass of the carbon and oxygen, it will become 44 gram. Okay, 44 grams of carbon dioxide and 2 into 18 grams of water, forming what? 44 grams of carbon dioxide and 2 into 18 grams of water. So by this, we can express this following equation in terms of masses also. The last one is a volume. How to express it? We know that all gases can occupy the space of 22.4 liters. It can occupy the space of 22.4 liters. So we can say that 1 volume of methane reacts with 2 volumes of oxygen, forming 1 volume of carbon dioxide and 2 volumes of water. Or we can express in terms of this liter also. How we can? 22.4 liters of methane react with 2 into 24.4 liters of oxygen, forming this carbon dioxide. How much? We need to calculate it with the carbon dioxide and also with the water. This is how, by using the volume, by using the gram in terms of mass and also in terms of mole and also with the molecule, we can express the reaction in the 4 different ways. Okay, this is all about the stoichiometry. Remember, in the stoichiometry, we are going to discuss only, or we are going to calculate the amount of the reactant or the mass of the reactant and the mass of the product that are involved in a chemical reaction, and we can express it in the 4 different ways. One is with the mass, one is with the molecule, and also one is with the mass, mole, and also with the volume. Let's see how to do the problem now. So this is one of the important problem which is asked so many times in your examination. Okay. So let's see how to do this work. So calculate the amount of water produced by the combustion of 16 gram of methane. So what they are asking to calculate? The amount of water which is formed by the combustion of 16 gram of methane. What does it mean? So we need to calculate the relationship between the mass and the mass. So this is a mass and mass relationship calculation. How do you say it is a mass and mass? Because they have given the combustion of 16 gram of methane, means it is expressed in terms of mass. Okay. What they are asking to calculate? The amount of water in terms of gram. So it is a calculation that involves the mass and mass calculation or the mass and mass relationship. Let's see how to calculate it. Okay. We know that this is a balanced chemical equation for the combustion of the methane, where 1 mole of the methane reacts with 2 moles of the oxygen, forming 1 mole of carbon dioxide and 2 moles of the water. Let's see how to calculate. From this above balanced equation, we can clearly say that 1 mole of methane gives 2 moles of oxygen, right? So 1 mole of methane gives rise to the 2 moles of water. So 1 mole of methane, which is equal to 16 gram of methane, because we are expressing the mole in terms of gram. So how to find out in gram? As we just now we come to know that we need to add the atomic masses. How to add? We know that for the carbon, the atomic mass will be 12 plus atomic mass of the hydrogen is 1 into 4. So it becomes 4. Total it is 16. So this is a mass of the methane or the gram of the methane. So 1 mole of methane, which is equal to 16 gram of methane. And 1 mole of water, which means to say that, so water means what? It contains oxygen and hydrogen. So what is the atomic number of water? So for the hydrogen, atomic mass will be 1d1. Since it has a 2 hydrogen, 2 into 1 plus for the oxygen, that is 16. So it becomes 2 plus 16, it becomes 18. It becomes how much? 18. So it becomes 18 grams of water. So here we are considering only 1 moles of methane and 1 mole of oxygen. So that is 1 mole of methane and 1 mole of water. So how to express in terms of gram? I have displayed here. Okay. Now we can say that 16 gram of methane give rise to 2 into 18 gram of water. Why it is 2 into 18 gram of water? Because here the 2 moles of water will be formed by the combustion of 1 mole of methane. That is why this value of the water which is multiplied with the 2. That is why 18 gram is multiplied with the 2. So which is formed by the 16 gram of methane. So hence the 2 moles of water which is equal to 2 into 18 gram which is equal to 16 gram of water. This is how they have given the problem to express the relationship between the mass and the mass. Remember, from this formula they have given the mass, and from that mass we need to calculate the mass of the amount of water which is formed. Right? So how to do this? We know this equation, how to balance it. First we need to write this balanced chemical equation. Right? After that, from this we need to express in terms of mole. We know how to express in terms of mole. After expressing it, we need to convert into the gram, that is in terms of mass. Okay? Then we come to know that 1 mole of water can form 18 grams of water. Right? So but in our formula, we come to know that there are 2 water molecules will be formed. So it is multiplied with the 2. So it gives rise to the 36 grams of water. So this much of the water will be formed by the 16 grams of methane during the combustion. So this is how the things will be going to ask in your final examination. Understood? Next we'll move on to the next problem, that is, how many moles of the methane are required to produce 22 grams of carbon dioxide after the combustion? So what they are asking to calculate? To calculate the moles. They have given the mass. So here we need to calculate the relationship between the mass and the mole. We need to calculate the relationship between the mass and the mole. So they have given the mass in terms of gram. We need to find out the mole. How to do this? What we have to do? First we need to write the balanced chemical equation. We know that 1 mole of methane reacts with 2 moles of oxygen, forming 1 mole of carbon dioxide and 2 moles of water. And next, we know that this 44 grams of carbon dioxide is obtained from 16 gram of methane, which means to say this, the entire product which is formed from the 16 gram of methane and the water, right? So, the 16 gram, how does it comes? By multiplying the atomic masses of carbon and oxygen. Understood? So, the 44 grams of carbon dioxide is obtained from 16 gram of methane. Then we know that 1 mole of this methane which is equal to 16 gram and 1 mole of carbon dioxide is nothing but a 44 gram. So that 1 mole of methane which gives rise to 44 grams of carbon dioxide, but we need to calculate the x mole of methane which gives rise to the 22 grams of carbon dioxide. So this is a one we know from the equation. But what they are asking? The x mole of methane that forming 22 grams of carbon dioxide. So this is one we need to calculate it from the above problem. Understood? So that is why if you cross multiplied with this 2 equation, you will come to know that if you cross multiply like this, so 1 into 22 divided by 44. So you will get 0.5 moles of carbon dioxide. So 0.5 moles of carbon dioxide are produced, will be required to produce 22 grams of carbon dioxide. So here we will come to know that 0.5 moles of methane would be required to produce 22 grams of carbon dioxide. To produce 22 grams of carbon dioxide, we need 0.5 moles of methane. We need 0.5 moles of the methane. This is how in your examination, either they can give you the relationship between the mass and a mass with the volume. You need to identify it correctly and you need to solve the problem. I hope that you have understood with this problem. We'll move on to the next topic. that is limiting reagent or the reactant. We all know that when we are carrying out the chemical reaction, sometimes we have observed that one of the reactant will be not present as the reaction which is required, right? So most of the time when we are doing the chemical reaction, we have observed that one of the reactant will not be present as the reaction which is required. So that indicates that during any chemical reaction, one of the reactant will be present in the excess quantity, right? Whereas the another one which is present in the very low amount. So we can say that it is present in a very less amount. So that is usually find out by using a limiting reagent. Then what is limiting reagent? Limiting reagents are nothing but the reactants which are completely consumed during a chemical reaction. So the limiting reagents are nothing but a reactant which are completely consumed during the chemical reaction. What happened if the other reactant which is present in the lesser amount, then it is called as a excess reagent. So these are the reactant will not completely consumed and remain unreacted during the reaction. So these are the reactant, they present in the excess which are not completely consumed and remain unreacted during the reaction. They remain as a acid, hence it is known as a excess reagent. So these are the two terminology. While doing a stoichiometric calculation, you need to find out or need to keep it in your mind. What is the limiting reagent? These are the reactant which is completely consumed. So if one of the reactant which is completely consumed, so it will be limit the product. So another one will be remain unreacted, right? So that is known as limiting reactant. Coming into the excess reactant, these are the reactant which are not completely consumed and remain unreacted, right? So you can take the example of the formations of the water. Okay, so here you can see that the hydrogen combining with the oxygen forming water. Sorry, this is water. Okay, forming water. So here you can see that here I am considering the hydrogen as a limiting reagent and oxygen as a excess reactant. So if the limiting reactant reacts with the excess reactant, it will form a product. We know that any two reactant, if it is reacted, it will form a product. Here you can see that hydrogen is a limiting reactant because which is present in a, which is completely consumed during a chemical reaction, whereas the excess reagent which is not completely consumed, they remain as such. If you see this figure, see that water molecule which is formed by the combinations of hydrogen and oxygen, but remaining thing is water, that is oxygen will be remain as such, right? So that is why we can say that amount of the product which is determined by the limiting reagent. So this is all about the two different terminology which is used in the stoichiometry. While doing the calculation, you keep it in a mind. So in our next session, we are going to discuss with the reactions in the solution and its types. Okay. By this, I like to say that so in the stoichiometry, we are going to calculate the amount of the mass, or we can say that the mass of the reactant on the product which are involved during the chemical reaction. And it is very simple to understand the stoichiometry. And remember, most of the time they have asked you to calculate the stoichiometry, the relationship between the mass and also with the mass and volume. Try to work it out with the problem and watch this video. By this, I like to say that chemistry is very important. Only thing is you need to understand, and we will meet you in the next concept class. Till that, take care. Thank you.